So we're going to review a little bit in terms of what we learned on Friday. So you guys remember, if I give you a system that looks something like this, 4w minus 4z equals to -8, -3w plus 5z equals 0. How do we do? What do we do to solve this system? Okay. Yes, your basic. Yes. What do you do?
For this one, you multiply by common denominators. So
yeah. So you want to get a.
So either the w's or the z's will cancel each other out.
That's right. We want to make sure the w or z's cancel out. Which one do you think is better to get rid of, w or z? W. Okay. So what would you do to do that? We can't just add it right now, can we? Because then the variables won't cancel. Yeah, Danielle, what do you think? That's correct. You want to multiply the top equation by 3 and bottom equation by 4, which I did right here. By the way, you see how I'm leaving some space between these every time I write them down? Okay. So leave some space so you know which one. You know, if you were to not leave any space, you know, they don't look. You don't know which one is the first equation and which one is the second equation. Does that make sense? You could put a little squiggly line, yeah, if you like. Okay. Go ahead. I'll give you some time. Right now.
12w minus 12z equals -24.
Good. That's the first equation. Second equation?
Negative 12w plus 20z equals 0.
Yeah. So notice I have positive 12z on the numerator, negative 12z. I mean 12w and then negative 12w on the not denominator, on the bottom, right? So when I add them together, notice that w was to cancel, right? So Eric, tell me what to write. Good. And of course, when you get AC equals -24, divide both sides by 8, and you get -3. Okay, and of course, once you find that the z is -3, all you have to do is then plug it into your original equation. Which one would you like to use? First one or the second one? Doesn't matter, right? So did you all do this? What did you guys get when you plug it in? Yes? -5. Okay, I plug into I think the first one. You get, -5. So how do I write my answer? Is it -3, -5, or -5, -3? Yeah. That's right. Make sure you write this with the, them in a correct way. Otherwise, okay. So go ahead and, are we good? This is a nice review from what we did on Friday. Any question? How many forgot this right? Raise your hand. Good. Okay. If you didn't, do you see where you made your mistake? Yeah, most of you got it right. Okay. Try then. This one, it's a little bit interesting. Go ahead, try this. What are you gonna do first? Okay, first of all, how are they different than example 1? Fractions. Yes, Dieter?
It's fractions.
Yeah, we got fractions. Not only that, yes, Kevin?
What are the variables?
That's right. Look at the second one. You have the x on the left side and y on the other side. In other words, are these written in the form that we like? When we're doing the addition method, which form do we like in the addition method? You want a standard form. And does standard form have any fractions in them? No. So we want them in standard form. You guys remember? So you must have these. You must write this in standard form before you do anything. So first of all, in order to write them as a standard form, we have to get rid of all the fractions if you have in all these equations. So what do you think I'm going to multiply both sides by? For example, the first equation. Scott. Not GCF, you need the?
Or the LCD.
LCD, which is?
6 times 8.
Is it 6 times 8? Well, that would actually get you a common denominator, but not a least common denominator. Gary, what's my least common denominator? 24. I mean, if you could do it as 8 times 6, it'll work. So how do we know it's 24? What's a quick way of figuring out the LCD? You look at the denominators and you choose the bigger denominator, and does 6 go into 8? No. Okay, if it did, then that's the LCD. So if it doesn't, then what do? You do 8 times 2, which is what? 16. Does 6 go into 16? No. What do we try next? 8 times 3, which is 24. That's one quick way to do it, okay? If you forgot. If you don't want to do all this. So multiply both sides by 24. Oh, and then the bottom one. What should we multiply the bottom one? What is the LCD for y and 3? That's kind of it. Yeah. 3y. Very good. Did you all do this? Yeah, question? Oh, you did it by -3y? Oh, I see. So that's right. If you saw that already, then you will multiply by negative 3y, and then you could cancel those out. Yeah, okay. But I didn't see that, so I'm just going to first get rid of all the denominators, then I'll deal with it. It's okay to do that, okay? Who could tell me what to do? I mean, what do I get when I multiply the first equation by 24? Both sides. Get it?
3x plus 4y equals 24.
That's right. And what about the second equation? What's that, Jennifer?
3x equals -2y.
Good. 3x equals negative 2y. 3x equals negative 2y. Is that in standard form? No. So how do I write this as a standard form? Yes.
You add 2y.
You add 2y to both sides. What do you get on the right side then? 0. Okay. 0 is a number, guys. Okay. It doesn't go away. And now, Danielle, if you notice that it was negative 3, then that's good. I now multiply by negative 1 because I have 3x and then bottom here I got positive 3x. So when I do, I get this. Okay. I get 3x plus negative 2y equals to 0. Notice I am pairing them every time. You see I have some space in between them and so forth. Okay. Don't do that. If you imagine if you wrote everything without any space, you don't know which one is which then, right? Don't get that mixed up.
-2y plus -2y. Isn't it just 2y?
No, what's negative 1 times 3x plus 2y? Isn't that right? You have to distribute the negative 1 to the...
I multiplied the top one.
Yeah. Oh, you multiply the top of my... That's okay. You can multiply the top of my negative or the bottom. Okay, then when I add them together, Nathan, what do I get?
You get 4y, but 4y equals 48.
Really? No, when I add them together, the x's cancel out. So,
Oh yeah, so x's cancel out.
so I get...
4y.
What is 4y plus negative 2y? What do you get?
Oh yeah, 2y.
2y equals 2. What's 24 plus 0? 24. Isn't that right, guys? Then, of course, we divide both sides by 2. Y equals to 12. Pretty straightforward. By the way, do you think I should use my original equation to plug it in this time? Look at my original equation. They're kind of like fractions, right? So I could do that. I could plug it in and do that. This time I just used the equation after I multiply both sides by the LCD. Do they still have the same answer? If you multiply both sides by LCD? Yeah, so I could use these. These are all equivalent equations, aren't they? They all have the same solutions. So I chose, I think, 3x equals negative 2y. Is that okay to plug it into that one? If I wanted to? Because I didn't want to deal with fractions. Okay. Doesn't really matter, does it? Okay, so then when I plug it in, how many people got the x? Who's got the x? Jennifer, what'd you get? Negative 8. How many people got negative 8? Very good. So Sang, what is my solution? Negative 8, 12 is correct. There you go. Okay. How many people got negative 8, 12? Both of them? All. Good. Is this a nice review of what we did on Friday? Okay, so tonight, guess what? You're gonna have these type of problems. Okay, and then you're gonna have some word problems. Not too many. Not too many. Okay, how about then? Why don't we try this one now? Kind of similar to the last one. Go ahead, everybody try. All right. So, what did you do for the first equation? Multiply both sides by Jeffrey.
You multiply all sides by 12.
That's correct. And then what about the second one?
2.
Yes, 2. That one's simple. Who can tell me what I get when I do this? Amber? Good. 3x plus 4y equals 24. And then what of the bottom one? Stephanie? Good. So, your question?
Did you multiply the bottom one by 4 since it's like the top one is going to equal 4y?
All right. If you already saw that, yeah. Very good. If you see that already, multiply, instead of 2, multiply by 4. But here, then I'm going to do that. So you could just do one more step like this. Okay. Very good. So now I multiply by 2. Now, what Danielle is saying is if you would have seen that, you would have multiplied both sides by negative 4. Then you would cancel out. So you get this, don't you? Are we good with it there? Nick, tell me what to write next. When I add them together now? I'm ready to add. Good. 5x equals 20. How many people got x equals to 4? All right. And once you got that, I mean, you shouldn't make any mistake of plugging it in. How many people got the y? What did you get as your y? Okay. 3 is correct. Okay. So I used the first equation. Okay. After I actually used not the original one. I used the one after I get multiplying by LCD first. Is that okay if I use that one? Yeah. It's just they have the same solution, so it doesn't matter.
So it's 4, 3.
Yeah. 4, 3. So as long as you don't make any mistake of multiplying both sides by LCD. Are we good with this?
Yes, we are.
Yes. Easy. All right. So that's it then. Get out your